Hello students, see here, today what we have to discuss, the very famous name reaction, that is benzyl to benzylic rearrangement. So that is very important according to JE point of view. The reaction mechanism and the applications is very important. Please be focused. Let's begin the benzyl to benzylic rearrangement. First reaction, see, observe careful my dears. Phenyl group, diketones. This is what? Benzyl, my dears. Benzyl. In presence of base, that is NaOH, in acidic medium, what will give? Benzylic acid will give. Benzylic acid. Benzylic acid. This is benzylic acid. See, this is very important according to JE point of view. Please be focused. See, this is a reaction and mechanism is very important, and applications is very important, my dears. So be focused. Now observe carefully here. First, NaOH, how it dissociates? Na plus, OH minus, right? OH minus. Now here observe careful, my dears. Please be focused. Here benzyl, C double bond, right, benzyl. Observe carefully here. OH minus. Here, be focused here. The bond breaks, heterolytic cleavage takes place. So that is the reason what happens. Oxygen gets negative charge, carbon gets positive charge. Right? The heterolytic cleavage takes place. So that is the reason what happens. Oxygen gets negative charge and carbon gets positive charge. Now see here. This OH minus attacks at positive site. See, OH minus attacks at positive site. Why? Because that is OH minus is act as nucleophile. Now observe careful. Negative charge and positive charge becomes one bond. See, my dear students, humble request, especially 11th and 12th standard students, positive charge and negative charge will becomes one bond. So here the OH minus and carbon plus, it makes one bond, my dear students. C double bond, CO minus, right? Phenyl group, OH. Now observe carefully. This is very important step. Observe carefully, my dears. Here, this alkoxide ion, due to this alkoxide ion, plus R effect, due to this alkoxide ion, plus R effect. So what happens? Due to plus R effect, due to plus R effect, bond breaks and migrates phenyl group. See here, my dears, due to plus R effect, so what happens here? Observe careful, this bond will be breaks. So this phenyl gets what happens? Negative charge. Right? Now this phenyl group migrates towards this carbonyl compound. So here first bond breaks, negative charge, positive charge. Now here observe careful. This negative charge attacks at positive site. Here, the one positive, one negative will becomes what? One bond. Observe carefully here. This one positive charge and negative charge will becomes what? One bond, my dear students. Please be focused. That is very, very, very important. Now here, observe careful. This step is very, very important. Phenyl group, right? Sorry, this gets negative charge. Here, this phenyl group, migrated phenyl group, and C double bond, O minus. Observe carefully here. Sorry, not O minus. OH. See here. Now, observe careful. What happens the next step? Proton transfers. Proton transfer takes place. See, what is the reason the proton transfers takes place? I will explain you, but now you have to observe carefully here. Now the heterolytic cleavage takes place. Oxygen gets negative charge, hydrogen gets positive charge. This H plus will attack it here, right? One negative, one positive will becomes one bond, right? So what is the step? Phenyl group, COH, phenyl group, C double bond, O minus. Observe carefully here. Now, what is the reason, sir? What is the reason the proton transfers? So what is the reason the proton transfers? The reason is that, observe careful, this alkoxide ion is unstable. So why, sir? Why? Because these phenyl groups is electron releasing groups. So that is the reason oxygen gets negative charge, more negative charge. So that is the reason this oxide ion will unstable due to electron releasing groups are attached to this carbon. So that is the reason what happens. Oxygen net charge will increases. So this is unstable. So that is the reason proton transfer takes place. I repeat, see here, this oxide ion is unstable. Why, sir? Why? Because these phenyl groups are electron releasing group. So that is the reason oxygen get more negative charge. So if charge increases, the stability decreases. Charge increases, stability decreases. So that is the reason this H plus will be migrate. Sir, okay, clear, sir, clear, sir. Then here, sir, here oxygen gets negative charge. So it is not unstable? Sir, this is stable. Why? Because, observe carefully here, due to resonance, this oxide ion will be stable, right? I hope you clear, everyone. I repeat once again. See, the proton transfers takes place. So what is the reason? Actually, the reason is that if the phenyl groups are electron releasing groups, so that is the reason what happens. Oxygen gets more negative charge. So that is the reason it is very unstable. Sir, here also alkoxide ion is negative charge, but that is stable. Why? Because this alkoxide ion charge will participate in resonance. So that is a very, very, very important. So be focused. Now here, the last step. The last step is COH, C double bond. Sorry, this is not OH, C double bond, OH. I hope you clear, everyone. So this is H plus attacks it here. I hope you clear, everyone. See, in acidic medium, H plus will attacks it here. The what happens finally will get benzylic acid. So benzyl to benzylic acid. So that is the reason this is called as benzyl to benzylic rearrangement. This is what? Benzylic acid. I hope you clear, everyone. So my dear students, humble request, please take down. few applications. See here, observe carefully. First application. Right? In presence of base, that is NaOH, in acidic medium, that is H plus. To give this is OH, this is C double bond OH. This is first application. This is first application. Now second application, see. Observe careful. Second application. Here. Very, very important. This is last time JEE mains in asked in JEE mains. Double bond, right? Presence of base and acidic medium. So what happens? The product is this is OH, this is C double bond OH. See, this is second application, my dears. See how it will come, this second application. I will write and I will explain you. Observe carefully here. I will write like this, so that time you will be understand more. Observe carefully here. Double bond. Now here, what happens? OH minus, that will be attack set here. Clear? Right, heterolytic cleavage takes place, oxygen gets negative charge, this carbon gets positive charge. Clear? Right? So, what is the product? What is the next step? Sorry. The next step is O minus OH. This will get. Now, due to place R effect, what happens? This bond will be migrates here, right? It gets negative charge. This bond will breaks and it will be migrates here. Now you observe carefully. What happens? The next step is that is observe carefully here. This O minus, this is OH. So finally, what happens? H plus attacks it here. The product will be, this product will be obtained. See, observe careful. I repeat. See, first heterolytic cleavage takes place. Now OH minus will attack it here. So after that, see my dears, due to plus R effect, so bond breaks and migrates. So finally, what happened, my dear students? Finally, we'll get this one, my dear students. So already we discussed in reaction mechanism. So need not to take this. Otherwise, if you want, pause and take. So, right. This is second application. Now see third application. That is C double bond and C double bond This is called as fural, my dears. No need to bother about the names, but you have to remember the structure, my dears. See, fural, what happens in presence of base, right, and H plus. So what happens? So here, observe carefully here. Fural, right, so benzylic rearrangement will happen. See, like this is also benzyl to benzylic acid like rearrangement. I hope you clear, everyone. So my dear students, please take down this. So 3 applications. I hope you clear, everyone. Please take down. Now, see one more very important point. That is, observe carefully here. Observe carefully here. Here one CH3 paratolulyl, diketones, observe carefully, my dears. P focus. Here, this one is first carbon, this one is second carbon. First carbon and second carbon. Now here, the base there, right, base, clear? Now this base will attack set here or else here, where it will be attacks. Observe careful, what is my question? The question is that this OH minus will attack set here, first carbon or else second carbon. So that is a very, very important. Once you pause the video and think that. Observe carefully. This OH minus will attack at first carbon, or else this OH minus attacks at this carbonyl compound, this carbonyl group, second carbonyl group. So which place the OH minus will attacks? Pause and think. See now, I will explain you. This OH minus will attack at here, beta. Here. So I will explain you. Observe carefully here. If it is heterolytic cleavage takes place, it gets negative charge, right? It gets negative charge. The first carbon gets positive charge. Now here observe careful. It breaks, heterolytic cleavage takes place, it gets negative charge. What happens? The second carbon also gets positive charge. Now observe careful here. Here what happens? This paratolulyl group are more electron releasing group. See, paratolulyl group more electron releasing group than the phenyl group. So what happens? Observe careful this statement. This statement is very, very important. Paratolulyl group more electron releasing group than the phenyl group. So this is what? This is phenyl group. This is what? Paratolulyl group. So paratolulyl group is more electron releasing group. So that is the reason. What happens? Observe careful. This is more electron releasing group. So that is the reason this positive charge will decreases. This positive charge will decreases due to more electron releasing group. Positive charge will decreases. So that is the reason this OH minus will attack at first carbon. I hope you clear, everyone. First carbon, this OH minus attacks at first carbon due to the positive charge is more than the second carbon. So this OH minus will attack at first carbon. I hope you clear everyone. So what is the next step? See here, observe carefully here. This is para-tolyle, more electron releasing group. So O minus CH3 OH, sorry, this is phenyl group. Now observe carefully here. This plus R effect, due to plus R effect. See, due to plus R effect. Plus R effect means what? The electron donating release, sorry, electron releasing and electron donating is called as what? Plus R effect. Observe carefully, due to plus R effect, this bond will be breaks and this phenyl groups migrates to here. Observe carefully, this bond will be breaks, right? This bond breaks, right? Bond breaks and migrates due to plus R effect. Due to plus R effect. See sir, I repeat once again. Listen carefully here. Observe carefully. This alkoxide ion has negative charge, so that is the reason it shows plus R effect. Point number one. Now this plus R effect, due to plus R effect, what happens? This bond will be breaks. After that, this phenyl group will be migrates to this carbon. So this gets negative charge, gets positive charge. So the one positive, one negative will becomes what? One bond. This will be gets negative charge. This phenyl gets negative charge. Now this phenyl gets negative charge. This negative charge and this positive charge will becomes what? One bond. One bond. So now see what is this next step. Observe carefully here. Phenyl group O minus right, C double bond OH. Observe carefully here. See this alkoxide ion is very unstable, my dears. Why? Because this para-tolyle group, electron releasing group, and this phenyl also electron releasing group. So what happens here? The electron charge increases on this alkoxide ion. So that is the reason proton shift takes place. So this gets negative charge. Hydrogen gets positive charge, heterolytic cleavage takes place. Now the proton shift takes place. That is very important, my dears. Observe careful. So here, finally, what is the step? This is para-tolyle and COH. Here one phenyl group, right? C double bond O minus. See sir, then this is also alkoxide ion, but it is stable sir. This is stable sir. Why? Because it participates in resonance. So that is the reason that is very stable comparatively this alkoxide ion. So this is about few application, my dears. See here, what is the important? The OH minus will attack at first carbon. Why? Because here the positive charge is more than the second carbon due to para-tolyle group, more electron releasing group than the phenyl group. So here the positive charge decreases. So that is the reason OH minus attacks at first carbon. Please take down, my dears. Please take down. This is benzyl to benzylic rearrangement, my dear students. So this is yours, Ravish. Take care. Bye-bye.